Hello everybody, back again for another riveting math video, Oscar worthy of course. Today we have to cover constructions and the circle. As you remember, we went over a construction earlier in the unit on how if I have three non-collinear points, how I can get a circle through those three non-collinear points. Now we have to find out how we can do a tangent line, a square inscribed in a circle, a hexagon, and an equilateral triangle inscribed. So there's going to be 4 total constructions we'll go through in the next 10 to 15 minutes. The first one here is going to be how can I construct using my compass and a straight edge a tangent through the given point on the circle. And if you remember the definition of a tangent, it's a line that intersects the circle in exactly one spot. So on my circle here I have point P. I would like the tangent to go through point P using your compass, not just lining it up with a straight edge or a ruler and drawing a line through that looks like it's tangent to it. So at any time during this video you need to stop and do the construction yourself. Feel free. That's the great thing about doing this video with constructions today, is that you can stop it whenever you want and practice yourself. So how we're going to make this line tangent to the circle going through P is we're going to use one of our theorems, which says the following. If P is going to be our point of tangency, remember, and I draw a radius to that point of tangency, you'll remember from our theorem that that radius will be perpendicular to the tangent line. So really what I'm asking you guys to do now is through this line segment that I've made, and we are going to have to extend it a little bit. So let's back up a little bit and get our line out. What we're going to do is we're going to make a line perpendicular to this extended radius going through P. And if you guys remember how to do a perpendicular line through a point, we've done it multiple times this year. It is what we refer to as the happy or the sad face. So I'm going to place my compass point on P. And I am going to make an arc that intersects that line in 2 different spots. So 1, 2. I always like to open up my compass a little wider after that. Go to each point of intersection right now. And make 2 more arcs. So there's the first one. Leave your compass setting the same, and we go to the second opening, or the second point of intersection, and make the second arc. We are going to take our straight edge, line that point of intersection up with point P, and draw in your tangent line. Look at that view right there. Alright, that's a little off, so let me, there we go, still a little off. There we go. Perfect. Okay, we know that line has to be tangent because the radius is perpendicular to it. All right, so that is how we construct a line tangent to a circle through a given point. We're just going to do an old construction that says putting a perpendicular line through a point. All right, moving on to the next one. Oh, hold on. Can't start the next one. Ali, you in class? Probably hasn't shown up yet. But anyway, moving on. How to do a square inscribed in a circle. If you remember the definition of an inscribed polygon, that means all vertices need to touch the side. So how can I get a square in here? Remember the square, all sides have to be equal. All right, all the sides have to be equal. First step to this construction, and I'll tell you why it comes out to be the way it does at the end. We're going to make a diameter. Anywhere in the circle. Anywhere. We're going to make a diameter. Now with the diameter, right now we have 2 congruent arcs. And if you remember, a square has 4 sides, so I kind of want 4 congruent arcs instead of just 2. So the way we're going to get 4 congruent arcs is we're going to take our diameter and bisect it. So we're going to do the perpendicular bisector of your diameter. So we're going to open up our compass a little wider, more than half the length. We're going to make a decent size arc. Beautiful. Go on the other side of the diameter. Make another decent size arc. And again, line up our straight edge. You should get a second diameter now in your diagram. Perfect. And now what you see is we have cut our circle into 4 congruent arcs. And now we're about to apply a theorem that says if the arcs are congruent, then the, what are we drawing in right now here? chords are congruent, let me do it in dash so you can see it a little better. If the arcs are congruent, these 4 chords that I'm now drawing in with my straight edge are congruent. And that ensures me that all 4 sides of this quadrilateral, because they're chords with congruent arcs, those 4 sides are all congruent, meaning I have my nice, beautiful square. So I'm drawing a diameter and then bisecting that diameter. So that is how to get a square inside your circle. All right, let's challenge ourselves now a little bit. A hexagon. So you're thinking to yourself, okay, let's try to compare it to the square. The square had 4 sides, so it had 4 arcs that were congruent. Can I divide this up into 6 congruent arcs so all 6 chords are congruent? All right, and the answer is yes, we can. And at the end, just like I did before, I'll show you why it works. First thing we're going to do is just draw a radii somewhere in the circle. All right, let's draw the radii. Then we're going to take our compass and we are going to measure that radii. So measure the length of your radii right now. And now from that point, notice my compass point right here. That's on where the radii intersected the circle. What I'm going to do is, using the length of the radius, I'm going to go around the circle and make arc lengths that are the same length as my radius. So I come down here, make an arc, put my compass point on that arc. Again, all these arcs I'm making are the length of the radius, and I'll show you why this works in a second. And we're going to try to get 6 congruent arcs. There we go. And one more. There it is. So now you'll see we have, ready, 1, 2, 3, 4, 5, 6 congruent arcs. So what we're going to do with those, same thing we did as the square. We're going to connect them. And you will start seeing the hexagon being formed. All right, all lengths being the same. Now, why does this work? All right, well, remember at the beginning we drew our radii in? Well, let me draw another radii in, and we know from this unit that all radii in a circle are congruent to each other. And remember, what is the length of this arc? It's the same length as the radius. So in this triangle I formed here, yes, the 2 radii are the same, but so is this chord. Its chord is congruent to the other 2 radii because the arc length, remember, has the length of the radius. So drawing it out here, what type of triangle am I working with? I'm working with an equilateral triangle, which means all the degree measures are going to be 60 degrees. Ooh, what did I just put in there? Okay, a 60-degree angle, great. Thank you for the update. But I just put 60 degrees in an central angle right there. And if you remember, a central angle is the same measure as its arc. So all these arcs are going to be 60 degrees. I'm ensuring that this arc is 60, that arc is 60, and if you add them all up, all 6 times 60, 360 degrees. So that ensures me that I have a hexagon where all these arcs are 60 degrees, which means their chords will be congruent. So that is how I construct a hexagon inside a circle. And we're going to build off this now for our final construction, which is an equilateral triangle. Now, you're probably thinking right off the bat, okay, I saw how we did a square and a hexagon. So equilateral, I'm going to need 3 congruent arcs, so I have 3 congruent chords. That's going to be a tough one. How am I going to make 3 congruent arcs? Oof. All right. First thing, so that's going to be a little bit tough. First thing is we're going to do this hexagon construction. The first couple steps are going to be the hexagon construction. So if you remember the hexagon construction, we measure the length of 1 radius. So let's go back and do that. All right, so let's put that right here. Now let's start making arcs that are equal distant away. Okay, so here we go. There's our first one. Boom. Compass point. Again, pause this at any time. Let's keep going. I feel like I have to keep talking through this entire thing. I feel like I should be roasting somebody right now, but nothing's coming to mind. Good, right there. And here comes my final arc. Perfect. So again, we have the hexagon, but I don't want to make a hexagon. I want to make a equilateral triangle. So if you want to pause the video and think about how I would get 3 congruent arcs using 6 congruent arcs, go ahead and pause the video, think about it. Maybe talk to your partner next to you. If you do talk to anybody at all, that I know that would be new to some of you that just stay in the corner of your room all balled up on the weekends, but if you want to talk it over with somebody, pause the video. Okay, how are we going to get 3 congruent arcs? Well, we're not going to connect every single arc. We're going to connect every other arc. All right, so we're going to connect this one to this one, and this one to this one. And why are all those congruent? Because remember, they were all 60 degrees for the hexagon construction. Now if I just put 2 together, ready? 120, 120, and 120. And hey, that makes sense because all the angles in this triangle are inscribed. And the way I find an inscribed angle is taking half the arc. So if I took half of 120, that would ensure me that each inscribed angle is 60. And by definition, you have yourself an equilateral triangle. Amazing how this mathematics works out. So those are the 4 constructions you'll be mainly responsible for in this unit. You do have homework that is from the packet. Do we have any review questions? Yes, you do. You got packet page 50, which you can start right now, or you can start on review problem number 49, which are both assigned for tonight. Again, or just watch the video over because you thought it was that great. Again, thanks guys for watching this video, and hopefully it helped.